mass of lithium is required to produce 0.915 grams of lithium nitride. The other reactant is diatomic nitrogen. Now, this is going to be a mass-to-mass problem. But the first step of the problem is that we have to come up with a balanced chemical equation. Well, I have lithium. Lithium is reacting with diatomic nitrogen. It is forming lithium nitride. So this is a combination reaction. Is this balanced now? No. So I need to go through and balance the equation. So I'm going to start here by putting a 2 to balance my nitrogens, which would mean that I would need a 6 in front of lithium, correct? So now I have a balanced chemical equation. Thinking through the process in my head, I'm given 0.915 grams of lithium nitrate. I am trying to find the mass of lithium. So I am going to do a mass-to-mass problem. And my very first step is to convert what I have given, 0.915 grams of lithium nitrate, into moles of lithium nitrate. That is a flux capacitor move. How do I go from mass to moles? I use the molar mass. Okay? You've done that. So go ahead and convert this into moles of lithium nitride. I set up my conversion box. I want my grams to cancel. 34.8297 grams of lithium okay, is my number right there? 34.8297. Okay. Now, key point here, folks. A key point, and this is where I see a lot of mistakes. Okay? I see a lot of mistakes with this top part right here. Because folks want to come up to the molar ratio. Okay? This right here is a conversion. Okay? 1 mole equals 34.8297. Right? So that's going to be 1 mole right here. If you put 2 moles, what would 2 moles of that weigh? Twice as much, double that 34. Okay? A lot of people want to do that and go to the molar ratio. That's not yet. That's not yet. That's the next step. So, I make sure that my grams of lithium can cancel. I have now converted this into moles of lithium-3 nitride. Now, I'm going to bring in my molar ratio. I usually just draw another conversion box. Okay? I look and I say, okay, I want my mole of lithium nitride on the bottom. And what number do I get from my molar ratio? A 2. My balanced chemical equation, I get a 2. What am I trying to convert this into? Into what? Lithium. So on the top, I'm going to put mole of lithium. What do I get from my balanced equation? A 6. Now, do my labels in my factor label method, do my labels cancel? Yes. Okay? Folks, I've been preaching to you that it's important to put labels on everything. Here is why. Here is why that I've been preaching that. Now, my final part, I'm not done yet. I don't want moles of lithium, which I have right now. I want mass. I want grams of lithium. So I'm going to add another conversion box. What am I going to put on the bottom? Okay? This is just, once again, a flux capacitor back to mass. But I'm using different values. So what am I putting on the bottom? 1 mole of lithium. What goes on the top? My molar mass. Somebody peek on their periodic table. Mine's back there. What's the molar mass? 6.9 something, right? 6.941 grams of lithium. I do my cancellation. Factor labels. My labels should cancel. It did. So now I have my answer is going to be in grams of lithium. Is that what I am trying to find? Absolutely. So now I need to go through and do my math. Okay? Now, how do I do this? How do I do this? Well, the things on the top you multiply, the things on the bottom you divide, right? So there's a bunch of different ways you can program this into your calculator. Okay? I like to do all of my top first and then divide by my bottom ones. Okay? But that's just the way I like to do it. More than one way to do this, so whatever way you like to do it, go ahead and do it. And I come up with a value and I guess I should just get my answer sheet out to double check. I come up with a value. How many sig figs? 3 sig figs. So I come up with a value of 0.547 and box my grams of lithium. Any questions right off the bat on this one? So really, there's no new material. We know flux capacitor mass to moles, don't we? We learned last week the molar ratio. So the only thing is new here is the procedure of going from mass to mass. Okay, the procedure of going mass to mass. Well, what does this tell me? What does this tell me? Well, it tells me that if I want to end up with 0.915 grams, I need to have 0.547 grams of lithium and react that with excess nitrogen. Here's the first part of the second one. Go ahead and copy that down, and then we'll work it. Iron 3 chloride reacts with sodium carbonate to form iron 3 carbonate and sodium chloride. I love doing this because this just helps reinforce, okay, do we still remember how to write formulas of names? Because right here's 4 of them that you have to figure out. Is it going to affect your final problem if you do it wrong? 100%. We got to be perfect, folks. We got to be perfect. Iron 3 chloride plus sodium carbonate yields a double replacement reaction. Iron 3 carbonate and sodium chloride. Just stepping back, double checking iron 3, 3 plus carbonates and 2 minus. So we got to go to 6. Yeah, that's right. Okay. So, do I have a balanced chemical equation? I do not. Where am I going to start? I'm going to start right here because I want to balance up my carbonates first. Once I do that, I have 3 carbonates, 3 carbonates. I can see that now I need to have 6 of the sodiums. Now I got my sodiums balanced. Tells me that I need to have 6 chlorines, and that balances up my irons too. So now I have a balanced chemical equation. Go ahead with what I am given. 0.7 grams of sodium carbonate, and I am trying to find iron 3 chloride. A mass of iron 3 chloride, and I'm given sodium carbonate. So, very first thing I'm going to do, and while you were copying down the question, I calculated my molar masses for this particular problem. So I have 105.9888 grams of Na2CO3. Anybody do that? Did I do that correctly? Do our numbers agree? Okay. And that is 1 mole of Na2CO3. So I'm double check. My grams cancel. I have now converted this into moles, haven't I? My next step is to use my molar ratio. My bottom number is going to be 3 mole. Man, we'll finish this later, folks.